Okay, so let's have a little quick look at equivalent fractions and simplifying fractions. So we can do this two ways. Okay, so if we start with a fraction, for example, let's do 10 out of 20. To simplify a fraction, we need to find a number that both the numerator, the top, and the denominator, the bottom, are divisible by. So we want to find a number that we can divide 10 by and 20 by. So very easily on this one, we could divide it by 10. So if we divide the top by 10, we would get 1. And if we divide the bottom by 10, then we would get 2. So we would get a half. So 10 out of 20 is the same as a half. If I had 20 people in a room and I split it into two groups of 10, is the same as if I then took 2 people and split them into 2 groups. We're halving the amount that we've got. In the same way, we could have, instead of dividing that by 10, we could have divided it by, we could have divided it by 5. So 10 divided by 5 is 2, and 20 divided by 5 is 4. So what you must make sure that whatever you times the top, divide the top by, you do the same to the bottom. And then we could do that again. So we could divide this one by 2 because 2 and 4 are both in the 2 times table. They're both multiples of 2. So if I divide them by 2, I would get 2 divided by 2 is 1 and 4 divided by 2 is 2. So again, we've worked our way from 10 out of 20, 10 20ths down to a half. Let's try that one more time with another example. So we could have 15 out of 30. So you want to find the number that we can divide both the numerator and denominator by, which in this example, we could divide them by 5. So 30 divided by 5 is 6, and 15 divided by 5 is 3. So we've got 15 30ths, 15 out of 30 is the same as when we simplify that as 3 sixths, 3 out of 6. But again, you should notice that we could divide that again. So we can divide that by 3 because they're both multiples of 3. So let's divide the top and the bottom by 3. 3 divided by 3 is 1, and 6 divided by 3 is 2. So again, we've got down to a half. Now, they don't always work out to half, just these examples have. Let's have a look now then at the other way. So we're going to make our fraction, the numbers in our fraction, get bigger. So we're going to find the equivalent fraction, but making them get bigger. So let's start with a third. Now, this is really simple because all we need to do is times the top and the bottom by the same number. So let's times them by 2. So we're going to times the bottom by 2, which will give us 6, and we'll times the top by 2, which will be 2. And we could do that again. Let's times them by 5. Times the bottom by 5, times the top by 5. 6 times 5 is 30, and 2 times 5 is 10. And we could keep going and going and going. Now, the purpose of this would be if we wanted to make both fractions in a sum the same. So if I had a sum, for example, that was 2 fifths add 1/10, then I couldn't add that fraction as it is because the denominator, the numbers at the bottom, are different. So to do that, I need to make them the same. Now, I could either simplify the fractions or I can increase the number in the fractions. I can't simplify 1 out of 10, so I'm going to have to change 2 out of 5, 2 fifths, to be the same as the 10th. So we want to make our 5 become a 10. So what do we do to 5 to make it become a 10? We times it by 2. So we're going to times that by 2, which means we need to do the same to the top of that fraction. So we're going to times the top of the fraction by 2 as well. 2 times 2 is 4. And now our sum, 5 times 2 is 10. I wrote 5. And now we can add our fractions together. So we put the 1/10 back in. So 1/10 add 4/10 is simply 5/10